The Lunar Leap, Apollo 11's historic mission. On July 16, 1969, the world held its breath. 3 astronauts sat atop a massive Saturn V rocket: Neil Armstrong, Buzz Aldrin, and Michael Collins. Their mission? To land on the moon. The Apollo 11 mission was the culmination of years of hard work. Thousands of scientists and engineers had poured their hearts into this project. 4 days after launch on July 20th, the lunar module Eagle separated from the command module. Armstrong and Aldrin began their descent to the lunar surface. Then, at 2017 UTC, Armstrong's voice crackled through the radio. "Houston, Tranquility Base here, the Eagle has landed." Hours later, Armstrong stepped onto the lunar surface saying, "That's one small step for man, one giant leap for mankind." For the first time in history, humans had set foot on another celestial body. Conspiracy theories, doubting the moon landing. Despite the overwhelming evidence, some people refuse to believe. They claim the moon landing was faked. These conspiracy theories began almost immediately after the event, and persist even today. The most common theory is that the entire moon landing was staged, perhaps filmed on a secret set. Believers argue that the US government was desperate to win the space race. Other theories focus on specific anomalies in the lunar photographs and videos, like strange shadows or the waving flag. These theories often ignore scientific explanations and the testimony of thousands of NASA employees. They dismiss the evidence from independent sources around the world. Instead, they cling to the idea of a massive, coordinated deception. The waving flag and other anomalies. Let's address the waving flag first. It's true that the flag appears to wave in videos from the moon, but this isn't because of wind. The flag was designed with a horizontal rod at the top to keep it extended. When the astronauts planted the flag, they rotated the pole, causing the flag to move. In the moon's low gravity, this movement continued for a while. Other anomalies in photos are often due to the unique lunar environment. For example, the lack of stars in lunar photos is easily explained by the camera settings needed to capture the bright lunar surface. Shadows that appear to point in different directions are due to perspective and uneven terrain. On Earth, we're used to flat surfaces and a single light source. On the moon, the uneven surface and bright reflections can create confusing shadow patterns. These scientific explanations debunk the so-called anomalies. The unique conditions on the moon account for these visual oddities. Missing tapes and lost data. One persistent conspiracy theory revolves around missing data. In 2006, NASA admitted they had lost the original tapes of the Apollo 11 moonwalk. This fueled speculation that the tapes never existed. The reality is less exciting. NASA had a habit of reusing tapes to save money. The moon landing tapes were likely recorded over. Fortunately, copies of the broadcast exist, recorded by TV stations around the world. Another point of contention is the missing telemetry data, detailed information about the spacecraft's position and condition. Some of this data has been lost over time, but losing data over decades is not unusual, especially with old technology. NASA has been open about these losses and made efforts to recover what they can. The missing data doesn't negate the mountain of other evidence that supports the moon landing. The overwhelming evidence from multiple sources confirms the authenticity of the moon landing. The lost tapes and data are unfortunate but not indicative of a cover-up. Section 5. Scientific evidence. Debunking the doubters. The scientific evidence supporting the moon landings is overwhelming. The Apollo missions left behind retro-reflectors on the moon's surface. Scientists on Earth can shine lasers at these reflectors to measure the exact distance to the moon. These experiments continue to this day, providing valuable data about the moon's orbit and rotation. If the moon landings were faked, how did these reflectors get there? Another piece of evidence is the moon rocks. Apollo missions brought back 842 pounds of lunar samples. These rocks have been studied by scientists around the world and have properties that could not have been faked. For example, they contain no water and no organic compounds. They also show signs of impact events that could only occur in the vacuum of space. Furthermore, the Soviet Union, America's rival in the space race, never disputed the moon landings. They had the technology to track the Apollo missions. If the US had faked it, the Soviets would have known, and had every reason to expose such a massive fraud. Instead, they congratulated the US on its achievement. The scientific evidence is clear and irrefutable. Section 6. Lunar samples rocks that tell a story. The lunar samples brought back by Apollo missions are a treasure trove of scientific information. These rocks are fundamentally different from Earth rocks. They tell us about the moon's formation and history. One key difference is the lack of water. Moon rocks contain no water-bearing minerals because the moon formed in a very hot environment. All the water boiled away. Earth rocks, on the other hand, almost always contain some water. The moon rocks also show signs of their extraterrestrial origin. They have tiny pits caused by micrometeorite impacts, which happen constantly on the moon's surface. On Earth, our atmosphere protects us from most of these tiny objects. The presence of these impact craters is strong evidence that the rocks came from the moon. Another fascinating aspect of lunar samples is their age. Some lunar rocks are over 4 billion years old, providing a window into the early history of our solar system. Section 7. Reflectors on the Moon, a lasting legacy. The retroreflectors left on the moon by Apollo missions are more than just proof of our visits. They're still in use today, providing valuable scientific data. These devices are simple in design but powerful in application. When a laser beam from Earth hits the reflector, it bounces straight back. This allows scientists to measure the Earth-Moon distance with incredible accuracy. We can now track the moon's position to within a few centimeters. One important use is in testing fundamental physics theories. The Earth-Moon system acts as a natural laboratory. Scientists can use it to test Einstein's theory of general relativity. The precise measurements from the retroreflectors help confirm the theory's predictions. The reflectors also help us understand the moon's orbit and its slow drift away from Earth. Section 8. Global Impact. A united Earth looks skyward. The Apollo 11 moon landing was a global event. It united humanity in a way few things ever have. An estimated 600 million people watched the moonwalk live on television. For a brief moment, people around the world shared a sense of wonder and achievement. The impact wasn't limited to the moment of landing. The Apollo program inspired a generation. It showed what humans could achieve when they set their minds to it. It sparked interest in science and technology around the world. Many of today's scientists and engineers cite the moon landing as their inspiration. The famous Earthrise photo, taken during Apollo 8, showed Earth as a fragile blue marble in the vastness of space. This image is credited with kickstarting the environmental movement. Section 9. Inspiring a generation of scientists and explorers. The Apollo 11 mission didn't just put men on the moon, it launched countless careers in science and engineering. Children who watched the moon landing grew up to be astronauts, physicists, and engineers. The mission showed that the impossible was possible. It inspired people to dream big and work hard. This inspiration wasn't limited to the United States. Around the world, young people were captivated by the achievement. They saw the power of science and technology to solve seemingly insurmountable problems. Many of these inspired youth went on to make significant contributions in various fields. The Apollo program also spurred advancements in education. Schools put more emphasis on science and math, and universities saw increased enrollment in technical fields. Section 10. Technological advancements from space to Earth. The Apollo program drove innovation at an unprecedented pace. Many technologies we use today have their roots in the space program. NASA needed to solve complex problems quickly. One famous example is memory foam, developed to improve crash protection for aircraft passengers. Today it's used in mattresses, shoes, and many other products. Another space-age invention is the cordless power tool. Apollo astronauts needed a drill to collect moon samples, leading to the first battery-powered drill. Medical technology also benefited greatly from the space program. NASA developed digital image processing to enhance moon photos, now used in CAT scans and MRI machines. Telemedicine, which allows doctors to treat patients remotely, was first developed to monitor astronauts' health in space. Even our food has been influenced by space technology, with advances in food safety and preservation techniques. Section 11. The continuing legacy of Apollo 11. More than half a century after Apollo 11, its impact continues to resonate. The mission proved that humanity could reach beyond our own world. It set the stage for all future space exploration. Every probe we send to Mars, every telescope we launch into orbit, builds on Apollo's legacy. The International Space Station, a symbol of global cooperation in space, is a direct descendant of Apollo. The lessons learned during the moon missions made long-term habitation in space possible. Today, astronauts from many nations live and work together in orbit. They conduct experiments that benefit all of humanity. Private companies like SpaceX and Blue Origin are picking up where NASA left off. They're developing new technologies to make space travel more accessible. The legacy of Apollo 11 is not just about reaching the moon, it's about pushing the boundaries of human achievement and inspiring us to tackle the impossible.